we're on time, so I think it's a good time to get started. Hey everyone that joined us. My name is Damian Schenkelman. I'm an engineer at Auth. I'm working on a number of things, but mainly authorization at scale. And one of the things we're wanting to do is do a series of Twitter Spaces conversations with subject matter experts around the industry. And today we have our first guest. This is the first episode. I'm here with Vittorio Bertocci. Vittorio, do you want to share a bit about yourself and your experience, what you do?
Sure. Thanks, Schenkel, for having me. This is a great series, and I'm honored to be part of it. So I also work in Auth0, just like you. I joined 3 years ago, so a bit after you. And at Auth0, I work as product architect, and I mostly split my time between helping specific feature teams to design their features in a way that aligns with identity practices. And then I work with the community, and in particular with the standards. And so I have a couple of standards that I'm leading development on. And in general, I participate in the community. One of the latest things we're doing is working with user agent vendors, so browsers, because they are adding features that are identity specific, and I'm a part of the conversation. I'm helping in there. In terms of experience, I've spent a lot of time in the identity space, a couple of decades probably, and I spent 17 years in Microsoft in different roles, but always in the context of identity, and mostly in the intersection between identity and development. Identity has always been, especially pre-cloud, the province of administrators. And very few people actually cared about helping identity, like identity for developers. And so that was the thing that I have done for many years. And then as soon as the cloud came along, it became imperative for everyone to actually, like for every developer to understand a bit of identity. And so I was already well positioned to help with that. And so I worked with the SDK teams. I worked with Office, with Azure, with various products that needed identity and needed to help developers to use identity. And then I did that for a few years. I spent time in the community. I wrote a few books. I did classes. So I tried to keep a foot in the developer space. So understanding what developer wants to do, regardless of how the sausage is made. And the other foot instead in the engineering and protocols of identity. So actually the practices of how this thing is made. And I always tried to be a bridge between the two, as in trying to make the two parts understand each other. And it's a never-ending work, because there's still the need for that 20 years later. But it's very rewarding. Let's say that whenever we manage to make identity simple so that developers can be effective with it, and whenever we manage to incorporate what the developer needs in protocols and in products, it's always a good moment that gives me a lot of satisfaction. And so that's why I stick with this topic, despite the fact that it's been really a long time. Yep, that's me in a nutshell.
Yeah, that's great, and thanks for the intro. You sound like the Marie Kondo of identity. It definitely brings you joy. You've been doing this for a while.
I try to sparkle joy, and it's an acquired taste. So I don't expect everyone to always enjoy it, but I do my best to make it enjoyable.
Yes, yeah, great. That's great. And again, thanks for the intro. A lot of the things, if anyone listening is interested, that Vittorio was talking about are things that he also discusses a lot in a podcast that he does, Identity Unlocked. So again, like those are things that you can go check out later, such as some of the work that's happening with the user agents and the browsers and other things. But that's not the topic that we wanted to discuss today. Today we want to talk about like authorization, and specifically authorization in the context of OAuth 2. So let's start there. What is OAuth 2?
So OAuth 2 today is in a constellation documents, specifications. It's like an entire ecosystem of guidance, which describes identity scenarios and helps developers, identity providers, like all the various actors that contribute to identity scenarios to know what to put on the wire and how to implement specific scenarios. But if we go back to when OAuth was just one specification rather than one entire ecosystem, the idea is that OAuth was born to enable one particular scenario, which was access to third-party APIs. Here, the classic example was back in the day, I'm sure that you experienced situations in which, for example, say that you would use LinkedIn or a similar app, and LinkedIn would occasionally tell you, hey, I would like to invite all of your contacts, like, for example, all of your Gmail contacts, to join you on LinkedIn, to add to your network. And in order to automatically invite them, how about, dear user, you give me your Gmail username and password, so I can programmatically reach out to Gmail and perform this invitation on your behalf. And this was, and unfortunately, still today, occasionally you still find it as a common practice, but there are many problems with this practice. In particular, one problem is that the moment in which you give your raw credentials to a third party, you cannot limit really what this third party can do. This third party can access your system and do everything that you yourself can do. And of course, that's a problem, because in this particular scenario, you might be interested in allowing LinkedIn to send those invitations, but you might not want LinkedIn to be able to read your email, for example. So we are already getting in the authorization space. And so OAuth, both its original formulation of 1.0, which now is out of fashion, and OAuth 2.0, which is the current incarnation, which we are still using today, were designed to allow a third-party API to grant delegated access to a specific client, so that the scenario that I described could occur with the user not having to give the raw credentials of a third-party system, so that, for example, LinkedIn could actually consume Gmail APIs without having to give to LinkedIn the Gmail account credentials of a user, and with a mechanism which allows limiting, scoping down what the LinkedIn client can do when calling those APIs. So in other words, managing delegated authorization for third-party clients. This was the main scenario. And then this scenario, like the specification grew to cover pretty much everything you can think of. Like this was a pure delegation and pure authorization, but then a lot of people were leveraging this mechanism to perform sign-in rather than pure API authorization. And so they were doing that in ways which were not very secure or interoperable. And so OpenID Connect was another family of specifications built on top of OAuth and built proper sign-in capabilities on top of it. And then new clients emerged, like, for example, your Apple TV can make API calls for example, calling Netflix, but it doesn't have a browser or it doesn't have a keyboard. And so it's a new kind of client, and OAuth was extended to allow you to use your phone, for example, to grant permission to your Apple TV to access a third-party API. And so on and so forth, like many evolutions. Like these things started when it was mostly websites and websites running on the server side. And then as we moved forward with JavaScript capabilities and more powerful devices, we started pushing more and more code to the JavaScript running on the client side in the browser. And so new scenarios that modified how this core of capability introduced in the first specification, it was stretched to adapt to these new scenarios. And then, of course, as we were using this stuff, we discovered things which weren't very secure. And so we started layering on top of the cores new guidance. And so today, OAuth is a galaxy of many different specifications basically describing almost everything you can do on the wire today when it comes to identity and authentication.
That's great. That's a very good recap of OAuth, and I like that you started from its origins, right? The delegated authorization, that main scenario of I don't want LinkedIn to have my Google email, my Google password. That's key, and then how many things were built on top of that. Now, like one of the key things there is like that's a very big description of what we can do with OAuth. When we look at the specifics, one of the things that I've seen typically happen is like, again, we have a client. In this case, it could be a web browser, it could be another like service running in the backend. You have this need to call this API, right? Like that's kind of like how everything started. LinkedIn wanted to call Google's API. How did that typically happen? What did OAuth provide, and how does that work under the covers?
So the core idea here is that OAuth introduced canonical roles that the various entities that are joined by a transaction can play. And in particular, OAuth introduced this idea of authorization server, which is basically a couple of endpoints. One designed to deal with the interactivity, and the other designed to be used programmatically, so from programmatic clients. And the idea is, if you are a resource, if you manage actually, here I have to be very careful because there are terms that are used in the spec that have a specific meaning, and then there are terms in English that also have some meaning, but I needed to make sure that I stick with the interpretation that is given to the spec. Otherwise, I'm going to be super confusing. But here, the idea is, say that you are Gmail, and you want to give the opportunity to third-party clients to access your APIs. The idea is you can either implement an authorization server yourself, or you can rely on an existing technology product stack that offers authorization server capabilities. And this authorization server basically supports one endpoint, which can be used for doing any interactive steps, anything that requires user interaction, and that's the authorization endpoint. And the idea is, if you want to allow a client to call your API, you can register this client in some form, like you will save somewhere the coordinates that define this client, an identifier, the URLs that this client uses for communicating. And then there is a specific format, which we call the authorization request, that the client can emit and can send these requests to the authorization endpoint, the interactive endpoint, and it basically say, hey, I am client X, you know me because I already registered. Here there's my identifier. Here there's a resource that I would like to access. And those are the things I'd like to do with this resource. And there is a particular parameter which we call scope, which allow you to specify what are the things you want to do with this resource. And then you can just make these requests to the authorization server. Now, the authorization server needs to authenticate the user. It needs to know who the user is and have some insight about what's the relationship between the user and the resource. In fact, in OAuth parlance, the user is called the resource owner. So in this particular case here, the authorization server would be Google itself. And before serving the authorization request, Google would have to authenticate the user, see that this user actually has a Gmail account, a Gmail inbox. And then at that point, the authorization server could present the user with what we call a consent dialog, which will say, hey, here there is a client X, which happens to be called LinkedIn, and this client wants to read your contacts and send mails on your behalf. Are you okay with this arrangement? And then at that point, if a user says, yes, I consent to this arrangement, then what happens is that the authorization endpoint will generate a code, which is just like a pointer to this decision, a reminder, let's say, and send it back to the user agent. And then the user agent would send this parameter back to LinkedIn, to the LinkedIn backend. And at this point, the LinkedIn backend takes this code, takes credentials. Let's say that when LinkedIn registered with the authorization server, it received some kind of credential, like you think of it like a shared secret, like a password, so that it can identify itself. And then the LinkedIn client would hit the other endpoint, which we call the token endpoint, presenting the code and showing that, yes, it is indeed the LinkedIn client because it can produce the credentials. And then at that point, the authorization server would look up the record associated to that consent operation, generate a token. If in this particular case, we call it's an access token. And this access token would enshrine the authorization decision, the consent decision, the delegated, I want to stress, delegated authorization decision that was made, and somehow either embedding it in the bits of the token itself or saving it somewhere on its backend, and then placing the token some kind of reference to that record and return that token to the client. At that point, the client, again, LinkedIn in our example, has this access token, and then the client can turn around and send this access token to the API it wants to invoke and perform the operation that it wants to perform. At this point, the API, which in the parlance of OAuth, we call the resource server, will receive the access token, and depending on the access token has been encoded, it will somewhat determine whether this access token is valid or otherwise. Possibilities are the token might be in a format which we agreed upon in advance, and there might be rules to validate this token, or there might be some mechanism that the resource server uses to send the access token back to the authorization server and decide whether the access token is valid. In the original formulation of OAuth, there was the assumption, not the requirement, but the assumption that the API and the authorization server were collocated. So in the Gmail example, the Gmail endpoints, the API endpoints, and Google are basically the same domain. So everything could simply be in a shared database that both the authorization server and the API can access. And the token could be simply the primary key of that table, so that you can just go once you receive it and look it up on the database. This was the original scenario, the reason for which they came up with OAuth to begin with. But the idea was that in OAuth 2 in particular, they wanted to separate the role of resource server API and the resource of authorization server, so that those two did not need to be collocated. And in fact, here, our sponsor of Zero happens to be an authorization server for rent, which typically lives in its own location, and the resource server can leverage that as a authorization server as a service. And then at that point, given that those two entities are not collocated, you need to find mechanisms to validate tokens, and one of them in particular is leveraging a particular format. But here, no matter how you get to that situation, the main point is the access token points to the things that the user consented to perform with that particular API. So that if LinkedIn uses the Gmail APIs for looking up contacts and for sending mails, everything will work. But as soon as LinkedIn tries to use the same access token for reading emails, for example, then the resource server will reject that request because the scopes that have been consented for that particular access token do not allow the client to perform that action on behalf of a user. So I know it's long and I spoke for a long time, so let me pause here and give you a chance to chime in if something wasn't particularly clear.
I think it was clear, but as you said earlier, I have been doing authorization authentication for a while, and I'm familiar with some of these concepts. Maybe I can do a short recap, and you can see if I'm missing any big things or any of the things that you were mentioning kind of like would get lost in the way. The first thing, let's say I'm LinkedIn. I'm trying to call Gmail's API. I need somehow to establish a trust relationship with the Gmail or the Google authorization server, and that's saying, hey, this is LinkedIn, I have a client identifier, these are my URLs. And then this is the typical experience that we probably all have had when we go to a site, which is we go to LinkedIn and then we have the sign in with Google button, and that sends us to Google. We see something there. That's the whole, okay, I'm redirecting you to Google. You're putting your credentials there so that you don't put them on LinkedIn. LinkedIn does not know your Google user ID and password. And then, again, Google apparently sends this code back to LinkedIn. There's a secret and a code exchange. So that basically says, hey, I'm the LinkedIn backend. I'm proving to you that I am really the LinkedIn backend by sending a secret that we agreed on before when we did that client registration. I'm also sending you the code that's related to this transaction. I get back a token. How does that sound so far?
It sounds great. I would just nitpick on a couple of things because otherwise that would not be me if I don't nitpick. And one is the trust relationship. The operation that you described there is the client registration. And I'm reluctant to use trust because in our context, trust is a very specific thing. And I reserve it to if I am a resource or a client, the willingness of accept a token that comes from a certain source and the willingness to believe in the content of the token, provided that I correctly validated it, is what I would normally use for trust relationship. Here is more of like the client needs to be known beforehand. There are flows in which you can register the client on the fly, but for Occam Razor, I would not mention them. And the other thing is that it's a subtlety. OAuth can be used also for sign-in if you abuse it a little bit, and OpenID Connect describes how to do it in the correct way. In the particular scenario of LinkedIn and Gmail, you would probably never see a button sign in with Google. It's more of, I'm LinkedIn, I get in a certain page in which it says, expand your network. And once I click on expand your network, it will tell me, would you like to use Gmail for sending invites to your contacts? And once I say okay, that's when I get transported to Google. And there might be a sign-in that occurs if I'm not signed in into Google, but that's just an intermediate step toward getting to that consent page that I wanted. So from the LinkedIn perspective, the sign-in occurred when you signed in with LinkedIn, which might have used something which has nothing to do with OAuth. And when I go to Google, I'm signing in into Google only if I didn't already have a session. And the only reason I do that is because Google needs to recognize me. But there is no sign in with Google button in LinkedIn in this particular scenario. Does that make sense?
Yes, it makes a lot of sense. Thanks for clarifying for me and for everyone. So now we got to the last part of your explanation, which was, okay, originally OAuth assumed that the API and the authorization server were collocated. In OAuth 2, that's no longer an assumption. How do we get this token that the client has when we send it to the resource server, the API, to actually tell us, hey, these are the things that the token grants access to, right? Like the scopes that we were discussing, without having a shared database between these two systems, because they might not belong to the same company even.
This is one of my favorite topics. And I see people in the call that know that, Aaron and similar. So here there's the point. The initial framers of OAuth refused to specify a mechanism out of the box, simply because there were already lots of changes with V1 and there were tensions. And so people weren't inclined to make too many changes in respect to V1. But then what happened was that the problem that you just described was a problem that everyone had to deal with. That's to say that given that the possibility of having a authorization server that lives elsewhere was really interesting for a lot of companies, people started doing that. And then two main mechanisms for dealing with that situation emerged. One mechanism is what we call the introspection endpoint. The idea is I don't care about the format of a token. Whenever I need to decide if a token is valid or otherwise, I just go back to the authorization server, and there was an extension specification on top of auth that described an endpoint and the messages that you send to it and messages that you should expect once you get back, in which you could basically go back to the authorization server as a resource server this time and say, hey, I received this token from the caller. What can you tell me about it? And then the authorization server would take this token, use whatever mechanism they devised for be stateful about it. Like, for example, this token might just be a pointer to the famous database that we had earlier. Or this token could actually contain all the information that you want, but be encrypted and signed and be opaque to anyone but the introspection endpoint in the authorization server. The authorization server would do whatever it takes to introspect this token and then return to the resource server a message saying, yes, this token is valid. I recognize it. I was the one issuing it. And here there is some content, like some things that you might want to know about this, such as, for example, if certain scopes were accepted, or various other information you might expect, like identifiers of a user and so on and so forth. That was mechanism number one, introspection. This mechanism has the advantage that it's not tied to any format. And you can use like really small tokens because they might just be pointers. So it has a lot of interesting things. However, this doesn't really scale all that well. Like imagine mega scale services such as our own, and imagine now all the resource servers phoning home every single time we receive a token. So another approach emerged as one extremely popular approach, which was to use a known format, and in particular the JWT format, and use known rules for validating whether this token was actually issued by expected authority, by expected authorization server, all independently from the resource server, so that the resource server can just follow a bunch of rules and decide for themselves whether this token is good without having to hit another endpoint and pay the network penalty of making this call or risk of being throttled and so on and so forth. And part of this was due to the fact that OpenID Connect, while building on top of the sign-in function, it took a page from predecessors like SAML and WSFed, which did use the SAML token format as a way of expressing the successful authentication occurred for a particular user and providing just-in-time claims as attributes that define the user in the context of that particular transaction. And so OpenID Connect adopted the JWT format and created one special semantic access token, which is a token meant for the client itself. And at that point, given that the client was the recipient, they defined this JWT format and they defined a set of rules that described how these tokens should be formatted, what kind of information you should expect, and how to validate it using JWT cryptography. And on top of this, they also defined a metadata format in which a provider can advertise the key that it will use for signing tokens and things like the identifier of an issuer and similar information. And so in other words, OpenID Connect created a heuristic for issuing tokens with a particular format and created the capability of dynamically at runtime acquiring the information to validating this token. Lots of vendors took this approach and applied it also to access tokens. So given that OAuth allows you to use access tokens in any format, this format was also valid. And so what happened is that the various Azure Active Directory, Auth0, many like Salesforce, Okta, the Identity Server, AWS, ended up all picking up JWT as a format for describe, for encoding their access tokens. The unfortunate thing is that OpenID Connect made that stipulation for ID tokens, which are very special semantic tokens, which are meant for the client in itself. They are not meant for calling a resource. And so they made no stipulation on how to express authorization notions, such as scopes. And also, it didn't really help define the audience in a format which is valid for an access for a resource server. So, in other words, companies adopting JWT, they had to do some modifications. They had to invent something for using JWT in the access token use case. And the outcome was that functionally, pretty much all of us did the same things. But from a syntax perspective, we ended up doing many different things. So you could have access tokens issued by provider 1 and from provider 2, which would be functionally equivalent, but they would use a different syntax. And here there's where my passion comes into play. I had to deal with this problem for many years. And so recently, like 2 years ago, I had the opportunity to propose during a conference a suggestion, as in like, could we create a profile that dictates how to do all the things that we are already doing today in interoperable fashion? And people liked the idea, and so we worked on this specification for a couple of years, and now we are at a stage in which we are at the last step for this thing becoming standard. Once it will become a standard, then JWT as an encoding mechanism for access tokens will also be an official way of doing things in the context of OAuth. Once again, I spoke for a really long time. Sorry, let me mute myself so you can chime in.
Great, this is great stuff. One of the things that, again, I take away from this is there wasn't a clear way to format this access token. People might have done different things, and specifically, again, the JWT format became fairly popular. A lot of companies use it. Difference is in syntax. Can you explain a bit, maybe quickly, what is a JWT and some concrete syntax differences, and what would the implications be of that, like across the industry?
Right. Sorry, I didn't think to introduce it, but you are completely right. We should have done it. So the JWT stands for a JSON Web Token, and it is a way of expressing a security token using JSON as encoding, and in particular by using the cryptography, which is defined on top of JSON. There are a number of standards that describe how to encode keys and how to indicate signing and encryption algorithms that all live under the collective umbrella of HOSE. And a JWT is substantially a set of user attributes. Some of those attributes codified in the JWT specification in itself, which describes some of the things that you might expect when the token represents an identity, which can be identity of a user, but also identity of a programmatic entity. So for example, there is one attribute which is called the sub, which stands for subject, and it is the identifier that is being used in the context of the transaction to identify the principal for which the token has been issued. And then there are like various other attributes which define the mechanics of how to validate or how to describe the parameters of a token, such as, for example, the identifier of the entity that issued the token, or various expiration information, as in until when the token should be considered valid and similar. And probably most important of all, the structure of this token is such that you can have this part that I just described, which is the body. You can have a header, which describes the way in which the token is secured, and in particular, how the token is being signed or encrypted and signed, as in using which algorithm and using which key. So you can have the identifier of a key that was used. And then the third part, which describes this JWT, is the signature in itself. So the idea is that you have this entity which is self-contained, which can represent attributes assigned to one particular entity. Again, most often than not, it's a user, but it can also be a programmatic principle, so a service or a machine or a device. And the idea is that this was defined in very generic terms, and then OpenID Connect picked that particular format and decided to use it for describing a token which represents a user, a signed-in user. And in particular, a signed-in user for an OpenID application, which in their parlance is a client. And so all the parameters, all the attributes that you would expect in a JWT used in an identity token as defined by OpenID Connect will reflect that particular scenario. So in particular, the audience parameter, which defines what is the intended recipient of the token, will have the identifier of a client ID. So that once the client receives this token, it can go check the audience and verify that, yes, the token was particularly issued with that particular client in mind, as opposed to a token which has been stolen still from the valid issuer, but intended for someone else. You can think of these as the classic bank check metaphor, in which the bank check actually has the recipient. And so if someone tries to pay you for your work with a check that was written for someone else, you know that it's best to work for someone else. It's not a good check. And so it's a similar mechanism. The challenge that we have, that I hinted at earlier, is that if you try to take an ID token and use it in a scenario in which the recipient is not the client, but it's the client that is trying to call an API, at that point, the ID token that you're using will have an audience, which is the client, is not the API in itself. So using the LinkedIn Gmail analogy that we used earlier, if I'd use OpenID Connect to sign in LinkedIn would receive, by using OpenID Connect, a JWT which contains as audience the identifier of LinkedIn in the authorization server. Whereas when I want LinkedIn to call the Gmail APIs, the access token that I'm using toward Gmail should have either directly in the token or in some other mechanism, but let's say JWT is so directly in the token, the audience should be Gmail. So by having people reuse some of the machinery that we created for OpenID Connect for calling APIs, now we are in trouble because, for example, the audience has a mismatch. Other things are the scenario that I described at the beginning for delegated authorization puts really a lot of emphasis on the scopes, as in scopes are what the user consent the client to do with the resource on their behalf. So as the name suggests, they scope down the privilege that the user has when accessing that particular resource. The ID token, it doesn't have any of this because the ID token is just signing in to the app. There are no permissions that are being asked or consented to. And so at that point, when people reused the ID token syntax in order to encode access tokens, they had to invent a way of representing scopes. And so if you examine access tokens created by various vendors, you'll discover things like someone will use the claim SCP, and they will place the scopes in that claim. Others will use the claim scope, as in the full word scope, and then place the scopes in there. And then in terms of the value, sometimes you'll have blank separated strings, like one string with each individual scope separated by the other by a blank, which is what OAuth describes as the request parameter. But others instead will use a JSON array. So the outcome of this is if you're trying to build an SDK, which can automatically evaluate the scopes that you have in the token, and you want the developer to just be able to decorate their methods with an attribute saying this method needs to have a particular scope and a scope value in order for me to allow the caller to perform this operation, Well, you can't do this. You can't do this because the SDK would not know from where to extract that information. It doesn't know what scope claim to use. And even if it would know, it would not know how to decode it because we didn't have a standard and because everyone had to invent this. Now that we have a profile, we have an official claim name for scope. We have an official mechanism for encoding it. And so now, if you know that the various parties involved follow that profile, then you can write an SDK that will automatically make this kind of consideration. And this one is for the scope, but in that profile, we added also other authorization-related attributes that can come in handy as well in both scenarios. Does that answer does it touch on the things you wanted to touch on?
Yes, yeah, definitely. So we now have the ability to go from, hey, we don't know what the format of the access token should be. Now we say, hey, it seems this JWT format was fairly popular. Let's try to agree on what that looks like. And this is kind of like how the work on the profile that you and some of the other members from the community did. What is the profile? Like, if I don't know the meaning of the word in the context of a standards body, what is a profile? What does a profile say? And then getting more into our specific topic, what authorization scenarios were you and the work considering, thinking about when working on that profile?
Fair. The ideal profile in general is a specialization of a more generic specification. Like specifications are designed to work with a wide range of scenarios, and they usually give a lot of freedom to implementers so that you can address a number of different use cases and situations without forcing people to go outside of the boundaries of a specification. The flip side of that coin is that if two implementers make very different choices, then they might both claim that they support a particular protocol, but they might still not interoperate because they made different choices. And so the outcome is they cannot talk to each other. So the goal of profiles in general in the world of specifications is to make specific choices, as in like, okay, let me take all the things that I can do using this particular spec, and let me make specific choices so that I narrow down the set of options that I want to use. And then at that point, if you narrow it down enough, you might get for specific scenarios in which if all the participants follow exactly the same options that that profile specifies, then you are guaranteed to interoperate. And so that's the spirit of profile, and that's the same spirit with which we created the access token profile for JWT, in which basically we say, okay, here you could do this in JWT, you have all the possibilities that the JWT offers, but now let me narrow this down, as in here there's the exact syntax I want you to use when you express with scope. Here there's the exact syntax that I want you to use when you are sending an entitlement, and so on and so on and so forth. So that's what we mean by profile in that context. Then, for what concerns the authorization scenarios, here we touch on one very, I have to say, controversial aspect of OAuth. OAuth is probably the most popular specification which has authorization in the name. And so, as a result, it created a bit of a man with a hammer syndrome, in which people that had authorization needs, they looked around for solutions and they found OAuth, and they often stretched OAuth beyond the intended scope that it was created for. At the very beginning, we gave the canonical scenario of LinkedIn gaining delegated access to the APIs of Gmail on behalf of a user. That is really it's not the only scenario that is possible by any stretch of imagination, but it is the one that was that prompted the creation of OAuth 1.0 and then 2.0. That is authorization, but it's a very special flavor of authorization. It's delegated authorization, in which an application accesses a third-party APIs on behalf of a user. And so the scopes, which are the artifact that is described by OAuth for carrying authorization information, have a very specific semantic, which is, those are the things that I want to allow among all the things that the user can do with that resource. In themselves, they are not granting that capability if that capability isn't there. So to give you a concrete example, if in the scenario that we just described, I give contacts.read permission, scope to my LinkedIn client when calling Gmail, that means that if Gmail is trying to access my set of contacts, if LinkedIn tries to access my contacts in Gmail, they can do it thanks to that access token. But if LinkedIn now tries to access the contacts of someone else in LinkedIn, then they will not be in Gmail. It's late. I'm starting to a short circuit. If someone else uses that same access token, which was issued for me from LinkedIn to get to the contacts in Gmail for someone else, that thing will not work. It will not work because the scope only says, this is the limited set of things that you can do on you'll see that people abuse scopes a lot, as in they use scopes as a way of transporting other authorization information. And as long as the two ends of the transaction agree on that particular use, and as long as that use reflects the actual policies that are applied to the solution, then everything is fine. The challenge is when you start trying to interoperate and you have the two parties having different semantic expectations. So coming back to the profile, one thing that I really thought was important to add was to add the claims in the access token profile that can help to express other constructs in authorization that are not directly related to delegated authorization. So in particular, we added group membership, we added entitlements. So we cannot really define the syntax of the value of those claims because every system uses something different. And other specifications, such as the scheme specification, which is more about managing resources, define the type of the attributes, but they don't define the syntax. They just say it's a list, but they don't tell you what's inside this list. But the main reason for adding this thing, which is roles, groups, and entitlements, was to give a specific place for implementers to carry this information. So that regardless of the fact that you are using OAuth, if you want to embed in the token the entitlements that the user has for a particular resource, now you have a place in the profile to do so. And with the understanding that the stipulation of adding or not adding that information and the format of the information is more about your own implementation than OAuth. Like OAuth doesn't have specific mechanisms for asking for those claims, just like it doesn't have generic mechanisms for other attributes. You can always add it, like if there are extensions, like extensions that allow you to ask for those particular attributes. But the main point is the way in which you decided to do this, the way in which you decide whether you attach these attributes once you already receive the resource and you have a local policy, or whether your authorization server knows that information in advance and you want to embed it in the token, those are all things that are up to you, and OAuth doesn't tell you how to do this. But now that in the profile we have these particular attributes, these particular claim types, now you know where to put them if you want to put them in there. And so once again, if we have SDKs, if we have policy engines that need to extract that information from the token, now we know where to put it. And so we can write that software in advance. at least we can write the software that extracts the values. Then once you have the values, you need to know more about the specific syntax of your system, but that's beyond the scope of a profile. Once again, I spoke a lot. How does it sound?
It sounds good. And so what does that mean? Like, does it mean now that I have scope and roles and groups and entitlements, and I can put all of that in my token, what does that mean for authorization scenarios? Are all of those solved? What scenarios aren't easily supported when I use a JWT?
And that is really strongly dependent on the specifics of the scenario. Yeah, and that's one of the super tricky things about authorization, which is every scenario will typically be a projection of an existing system. And you are using OAuth mostly because you want to make the resources that are part of your solution available when using a particular set of clients and when using a particular set of protocols. But ultimately, how many privileges you need to assign to a particular user in order to perform the operations that you are required to do, or whether those privileges are shared across multiple resources, or whether those things can be calculated already at token issuance time, as in I can see what resource you are asking for, and I can see who you are, and so I can embed this information directly in the token without making the token too big, or whether instead I need to have some calculation, some policy calculation, which occur once I actually perform the attempt to call the resource. Those are all things that are dependent on the system. So in other words, if I have a system in which I need to specify that my user is in the power of attorney role, then I know that already at the authentication time. And so I can issue an access token which has a role claim, which says power of attorney, and then the resource can use it. If instead I have a system in which I'm trying to access documents, and I have a very large number of documents, and my user belongs to different roles for these different documents, but I'm getting the token only once for calling the API, I will not get a new token every time I try to get a new document. Then embedding all the possible permissions in advance would be very difficult because I would end up with an enormous token. So the ability of embedding that information in the token, the syntax that says, yeah, place this information in this token in this format is not enough. You need to know more about your particular system, and you need to make decisions that are proper for the particular constraints that your system has. The other typical thing that happens is the things to the effect of, say, spending limits. You can embed the spending limit in your token, but ultimately, until you don't try to buy something, you will not know whether this token results in a yes or no. So the other thing that I'll just add as yet another example is sometimes the permissions between the privilege and permission assignment to user and resources happen with a really fast life cycle. And so the authorization server might not know. They might not, it might be too much of a chore for the people managing access to resources to every time phone home and let the authorization server know. So the authorization server might not be in the loop with the latest policies. And so it might not be able to embed the right information in the token. So long story short, there are many, many, many considerations that determine whether it's appropriate for the authorization server to embed in the JWT access token the authorization information, or whether the intelligence for making authorization decisions is more distributed and more factors need to come into play in a more distributed fashion.
Okay, I think I see what you mean. So there are cases where things seem to be more static, more stable, such as, again, I have a role in a system. So then the authorization server can put that data in the access token, and then when the resource server consumes it, it knows I have that role. But if there are things like as you mentioned, lots of documents. I'm a Google Drive user. Each time I need to access a document, if I need to request a new token, then that might not be ideal because it gets shoddy and the token is not very useful because each time I need to get a new one. So that things to start to get kind of like less useful. How would you qualify it? What are the implications of going in that direction?
Yeah, that's definitely the point. That's to say that here the specifications that we have are mostly tools to project the nature and the roles of the various moving parts of our system in a format that can be transported on the wire. And if there are if those things are really distributed and the authorization server doesn't know them, or if you'd be in conundrum, as you say, small tokens that are not very useful, or tokens that are really large, or that would be disastrous if they leak because we have too much of the because we have too much of a scope. Those are all things that need to be considered. And so at that point, it's hard to give a generic guidance that works for every case. It's more of you need to see what your system calls for, and then decide accordingly. The main thing that I would say is the naive solution is a naive solution in which, for example, you shove everything in scopes, or you expect the authorization server to put everything in the token every time, is a very dangerous one because it doesn't scale in a linear fashion. It might work well for toy scenarios, but then as soon as you go in production and you start dealing with large numbers, then suddenly it stops working. So here it's one of those cases in which it pays off to actually do some planning and understand what is going to be the usage at a regimen when your system is actually in production, rather than just doing a little prototype. And if a prototype works, then go in production with that approach.
Okay, that's good. And I have a follow-up question on that, but we have a couple of people that are requesting to speak, so I'll give them the mic. So let me first open this up for Julian. Julian, can you hear us? I think he's connecting right now. Let me see. Oh, wait, he dropped. So we have another request from Marcos. Let me also approve him. There we go. Marcos, can you hear us? Yes, we can. And we can also, Julian is back. So again, everyone, we should be able to hear everyone. I think Julian was waiting to speak first. Julian, want to introduce yourself and share what you were thinking?
Yeah, thank you, Schenkel, Vittorio. Yeah, I'm Julian. I'm Argentinian. I work for Google. So one thing that I found interesting, Vittorio, this is a question for you. It's that you were talking about interoperability in the context of access tokens, right? And I think the way how this specs evolved, right, when OpenID came up, interoperability has a very clear use case, right? It basically means identity federation. So there was a need for these tokens to not be opaque, and so that relying parties can basically look at it, recognize the user. So when you talk about interoperability in the context of access tokens and authorization, what are the use cases you are thinking? Are you mostly trying to accelerate, the open source in terms of people aligning and developing generic solutions for authentication or authorization, or companies building authorization as a service solutions? What is the motivation? What are the use cases?
So so thanks for the question. That's a very good question. There are two main parts. One is commonality of semantics, as in today people encoded access tokens in JWT making some big mistakes, or dangerous things, such as, for example, having multiple resources in the audience and having scopes which are unclear whether they apply only to one resource or more than one and similar. So the profile gives a very, very strict rules on how to do this. So it eliminates some of the ambiguity and the potential security issues that we had before. It's not strictly interoperability, but is uniformity, as in having people to use these mechanisms consistently. And the other is on clarifying the fact that scopes should be used only as scopes and not as, for example, other kinds of attributes. Then for what concerns the actual interoperability, actually in the wire, the main points are what I mentioned earlier. Like if you go on GitHub and you search on the things like ASP.NET or other development stacks, you'll see developers saying, hey, I want to be able to go on my method of my API and say, this method can only be called if someone has the scope document.write. Actually, there are values to this effect. And the answer that they typically get is, sorry, we can't give that to you because we don't know. Like once you get to these decoration attributes that you have on top of this, we don't know from where to extract this scope information. Because without the profile that we have in here, people might have just used any scope string and might have encoded that string in any format. Actually, not even a string, could be just an array or anything. So for development stacks, for API gateways, for anything that needs to consume this token, for policy engines that you might want to plug to things like entitlement, groups, roles, and similar. Today, there is no way of knowing how to extract this stuff from the wire. Depending on the, like I actually have a table which I put together while I was researching the topic, in which I had the various access tokens from Okta, from Auth0, from Azure AD, from AWS. And you can see that scope is expressed in many different ways. And groups, roles, entitlement, people do occasionally embed those, but they all use completely different names. So by having a consistent mechanism, now you can write anything that consumes and potentially also produces access tokens in a way that you know you'll be able to interoperate. And so now ASP.NET will be able to actually have an attribute that you can place on top of apps that can express requirements on top of your system, and it will be able to automatically evaluate these instead of having to write code that parses this stuff every time. And then there, like if you read the spec, there are many other things, such as, for example, when you're requesting an access token, the syntax for saying I want it for this particular resource, or what to expect when you are asking for a particular scope and how it is reflected in the token that comes out. Like, for example, if you want to identify the resource using a resource indicators, which is another spec, or if you want to do it by having scopes that are specific to the resource. There are a number of rules which help to make the request versus the outcome more deterministic. So that will also help interoperability, because if now we have two authorization servers that follow the same syntax, then you'll be able to more reliably ask for tokens and expect a more reliable outcome. Does this help? Julian is now back to listener, so he cannot tell me if it helps. Okay, so I'm just going to assume that yes, it does.
I will invite him to speak again. One sec. Not sure what happened there. Again, first time with Spaces myself. So, and in the meantime, I think we can hear from Marcos as well. Marcos, do you want to share your question?
Yeah, sure. So first of all, thanks Vittorio and Schenkel for the space. It's very interesting to speak about the things. The question that I want to basically to give you both is that we framed our authorization and JWT mostly from an external point of view of a use case, right? So you even like gave the example of LinkedIn, Google, and so on. But as you might know, like companies internally within the microservice architecture are starting to adopt this technology or this specification to also define those basically authorization systems within their own organization. My question is like, whenever you're doing this type of work, right, internally, you're trying to like secure your internal teams / applications tenants, whatever you want to call it, using this spec, is the design work that you need to do there different as if you're modeling the system as an external system? And also, are there any solutions out there that help with this? Because you need to have a central server that does all this authentication and authorization, because in this use case, and please correct me if I'm wrong, you can't use something like Auth0 for this, because Auth0 is like an external company, and you can't call each time your internal services communicate, you can't be calling Auth0 like an external provider, right? So how does it look for those use cases?
I think that a lot of these will come from Schenkel, because he can talk about Sandcastle. But in generic term, I would mention that whenever you have more insight about the system, you probably just should use whatever mechanism is available to you. Let's say that the JWT is specifically a consideration when you needed to communicate this information across boundaries. If you are in the context of a microservice, there are a number of solutions in which the various components of the service, once you are crossed the gateway, have a shared state. And the fact that once they communicate with each other, they are like within a trusted subsystem. And then at that point, encoding, it's not, like you shouldn't need to do that. Like you can use whatever works in your local system. You don't need to project these in a format that can cross a public network, because you are not on a public network. And also when you are designing your internal system, typically the resources that you are dealing with will already have their own hierarchy, their own set of permissions, their own mechanisms for assigning stuff. So all you need to do is to make sure that these things are available whenever and to whatever they are needed to, they need to be there. So probably the JWT profile in those contexts would not be particularly useful to you, apart from ingress, as in if there is some information, like if the user that is consuming this comes from the outside, then you'll want at the gateway to have all the references, all the identifiers that you need to resolve to reconcile the incoming user with whatever authorization information you might have locally. But then at that point, once you are within the microservice, I don't think that you'd have a lot of use of a JWT, because again, you are no longer crossing trust boundaries. And then I think that more from the product and Auth0 perspective, Schenkel will have a better perspective than I do.
Yeah, sure. So quick clarification, Marcos. When you're talking about like using JOTs internally, are you thinking about service-to-service authentication? Are you thinking about authorization? What type of scenarios were you thinking about?
Yeah, basically my use case is like the same situation that happens externally, but internal. Imagine that I have two APIs, service A and service B, which are internal to my organization. But in order for me to follow the least privilege principle, I don't want these services to be able to do all the operations between them, right? So for example, I only want service A to do reads on service B. And imagine that I choose JWT or like this spec to like define roles and audiences and all claims and all these entities that are worth for me to validate this. And I have like an internal authorization system that actually checks this. The question basically goes towards that way. Like do I need to model the system differently? Does it make sense to use this on an internal authentication scheme, or maybe I'm just like trying to overcomplex the solution?
Okay, I see what you mean. So the thing is that if you're using JWTs for something like this, who issues the JWT becomes a big question, right? So evidently the client service cannot issue it, because it could just, again, issue it, sign it, and then if that's a valid thing, it could put any data in the JWT that says they have a particular role or a particular permission. So that's not very limiting. You could have the server issue JWTs. So the server would need to say, hey, when a client tries to authenticate, I can give them a token with these scopes. That might create a bit more chattiness and overhead, and that's an option. Or you could have like an internal token issuance service that knows how to do these things. Now, from my perspective, that's probably a bit too much overhead. And the way I would deal with this is, again, assuming that you don't need to do JOTs, You can do mutual TLS for authentication. And then for things like authorization, if you want to do something like least privilege, I would just keep that state in the server. So the server should know, hey, this particular subject has these particular permissions to me. And that should work for most scenarios, especially if you think about like microservices and each service having their own state. Now, the problem with that is that each of your services would end up with its own authorization logic. And that's something that could be problematic. So what we're seeing, and again, I think you probably have seen this as well, is you're starting to see authorization being separated from the main service logic. And that's where we see some of these initiatives like OPA, with Rigo, with OSO, those policy languages that are trying to kind of like bring that logic out of the service so that it's clear across services and you can reuse those policies. So it might be not that just service A can see specific endpoints from service B, but also that services with a particular tag might be able to access services with another particular tag. And that kind of like gets into more like attribute-based authorization. And then if the number of items is fairly big, what ends up happening is that some of these like attribute-based rules are not enough to get you as fine-grained as you want. But that typically wouldn't be the case with a typical microservices architecture, because you might have 10,000s of services, but when you think about 10,000s of items, that fits in memory, and that's typically something that you can authorize externally with an agent or a library.
Yeah, if I can just add one meta comment on that. There is a reason for which we figured out authentication so well, and authorization is still kind of terra incognita, and like we are still discussing how to do it. And the reason is that it really depends. Let's say that having generic guidance that applies across the board is not possible. Let's say that the details of every system make a huge difference. As in, like even exactly the same topology, but a different number of permissions, or a different life cycle, or a different set of who can call whom, can make a big difference about what works and scales well, or what becomes a nightmare of maintenance, or that requires really a lot of overhead in terms of design. So I think it's hard to have a generic advice. The specifics of a system really make the difference between whether you want to have something which is independent and extracted from the service, or if it makes sense to inline some of the checks, because maybe some of the services are not really a yes/no, but they change the output of what you're doing. So there are like many different nuances that you discover only once you get to the specific of a service. So if you have a specific scenario in mind, and if you want to follow up, we can follow up offline, and we can play with your scenario as well if you want to.
Awesome, thanks.
Good. So as Vittorio was saying, again, one of the things that we are working on, and this is kind of like what led down this series of conversations, is precisely we're working on solving this like fine-grained authorization at scale problem. And that's where kind of like where the barrier for fine-grained authorization is. So like, again, typically, depending on how many services you have, the amount of like combinations might still be something that you can fit in memory. And because it's still an internal architecture, it's very latency critical, you can still make those decisions. Once you start getting into like the millions of objects and millions of combinations and moving things more towards the edge, that's where like these fine-grained scenarios that we are thinking about solving for come into play and kind of like make that bigger difference. And kind of like, at least from my side, my last question in regards to that for you, Vittorio, is, we've been talking a lot about, okay, I have a token, a JSON Web Token, JWT. It has some authorization information, but there are these cases where it's not well suited for them. Again, when I have lots of documents, I might end up with too many scopes, which results in like either the system having too many scope explosion, the token becoming too large, token bloat. What are the alternatives that you have seen for systems that have to go down that like fine-grained dynamic path, but also use JWTs as access tokens for authentication?
Well, it's kind of a cottage industry in which everyone does something slightly different. Again, very often with good reasons. But the most general case, I'd say, is the two big families. One is everything by reference. Let's say that the token only carries the enough information for the various resources and the various layers of validation, like gateways and similar, to look up the information they need. So a classic example for like the documents would be, here is the identifier of the user, and then the expectation is that close to the resource, there will be something like ledger record that says, here there's the ACL for this document with all the users and all the various permissions. And so the authorization really is done by the resource in itself. Resource or something close to the resource. The other alternative, which is not as common, is if you're using a particular system and this system has its own way of expressing privileges, then you might have a blob, an opaque blob that the authorization server embeds in the token, and then this blob gets rehydrated at a resource and evaluated in there. This is not very common because very often systems are tightly coupled, and so there is no expectation of serializing that information. There is expectation that the policy decision point is a line of sight from a resource. And so you rarely need to actually package it, move it across an untrusted network and unpackage it. So usually the classic solution when there is really a lot of stuff is to keep the policy close to the resource or accessible from a resource, and then to just provide in the JWT enough information to make the right stipulations at runtime.
Yes, that makes sense. One thing that you mentioned, which I just I know we talked about internally, when you talk about this blob, that other solution, the blob that we can hydrate, does the blob have data or does it have logic? How does that work?
That's like it depends on the system that you're using. Like if you are using a particular software, like I don't know, a CRM and similar, and they have their own way of expressing their own policy, let's say, then you'd use whatever they are using. So in other words, like you just take the intermediate calculation that they would do if they would have a line of sight and just provide it. So again, it's not very common. I've seen it used pretty rarely because usually the systems don't give you the intermediate, like they don't give you data. They just consume the data internally and they get to a decision. And so in both cases, they were always proprietary. And so it was opaque to the system. It just like here there is something that you need to ship to the resource, and the resource will know what to do with it. And whether it was declarative or whether it had rules, I honestly don't know.
Good. Yeah. That's a very interesting use case. I don't know if people in the audience have heard of it, but you can look up Biscuit by Clever Cloud, and they have a really interesting blog post about like this type of like hydration blob pattern where the token actually has some more of this policy data. And then, as Vittorio said, the other extreme, which is again having the policy close to the resource, keeping that data, that low latency solution is precisely what we're doing with Project Sandcastle, which is this Zanzibar-based implementation. So Google Zanzibar is an internal system that Google uses for their